A train full of passengers is travelling through the valleys. The train pulls up to the station, its final destination. The passengers get off the train, leaving it empty. The passengers disperse. Some visit the station cafe, whilst others leave the station by car in varying directions. This analogy can be used to describe diffusion, which is also referred to as simple diffusion. Simple diffusion is what we're going to be discussing today in my first video on membrane transport, which involves the movement of particles across a cell membrane. The train's passengers represent the particles. The busy train represents an area of higher concentration. When the train arrives at the station and the passengers disembark, this represents the movement of particles from a higher concentration to a lower concentration. Diffusion is the net movement of particles, molecules or ions, from an area of higher concentration to an area of lower concentration. Particles can diffuse across cell membranes, as long as they can move freely through the membrane. Particles diffuse both ways, but the net movement is always down a concentration gradient. The concentration gradient is the path from an area of higher concentration to an area of lower concentration. This continues until particles are evenly distributed throughout the liquid or gas. It's a passive process, so it requires no energy. Some examples of particles that diffuse across the membrane easily are oxygen and carbon dioxide. They're small, so they can pass through spaces between the phospholipids. They're also non-polar, which means they're soluble in lipids, hence they can dissolve in the hydrophobic layer. When molecules diffuse directly through a cell membrane, it's known as simple diffusion.